It's out of 50. Oh, Elise.
Well, to make it easy, you just make it out 100 if you want then.
Ooh, we
That
all
way you
get-
can just get a percent right away then.
Oh, no, it's alright.
Okay, that's what I thought. Okay, we gotta stay on the middle to stay on the video. Number one, some of you are not reading the directions carefully, because this question, well, I didn't make this quiz. This is Ms. Baker's one, but she's asking several things. Find an angle between 0 and 360 if it's degrees, between 0 and 2 pi if it's radians, that is coterminal with the given angle. Then find the exact value of each expression, and then draw a picture to show where the angle is located. So you gotta do three things. Because I'm not sure, some of you might have missed that. So, A, sine of 930 degrees. Now remember, when you work in degrees, if you add or subtract any multiple of 360 degrees, you're gonna be at the same place again, right? So what would be a good multiple of 360 degrees to subtract or add to this?
Oh.
720, right? Because you want the angle to be between 0 and 360. So if you subtract 720, what do you get? 210 degrees. See how that angle is between 0 and 360? And you know exactly where that is. Swing! Right there. So what is the sine of that angle? Which is the y-coordinate of that point. -1/2, right? So you gotta do three things. You gotta reduce the angle down, draw the picture, come up with the value. B, secant, -15 pi over 4. So when you work in radians, you can add any multiple of 2 pi to the angle and be at the same place, right? So what would be a good multiple of 2 pi to add to that? 4 pi. So you can add 2 pi, 4 pi, 6 pi, whatever, but 4 pi is good, because isn't 4 pi the same thing as 16 pi over 4?
Yeah.
And so when you add it, you get pi over 4, which is an angle between 0 and 2 pi. And then, I know that, because that's right there, right? Same thing as 45 degrees. So when I do this, I think, okay, what is the cosine of that? The cosine of 45 degrees, or pi over 4, is 1 over root 2. So to find the secant of it, you just reciprocatize it. Flip it over, and you get root 2. Swing! I don't know, how do you guys think about it? Yeah, so what I do is, do you guys have the, what do you call that app? Know your angles? Is it operable?
Yeah.
Oh, so no problem then, right? And does it have secant too, or does it have only sine, cosine, and tangent?
It has all of them. You can choose.
But you really only need sine, cosine, and tangent, right? Because everybody can flip over a fraction, right? I think. All right, C. Cotangent, that's not cotangent, fool. -17 pi over 6. What would be a good multiple of 2 pi to add to that? So you ask yourself, okay, 12 pi over 6, that's not enough. What about 24 pi over 6? Ka-ting! That's it. 24 pi over 6. So you get cotangent of, what is -17 plus 24?
Ooh, that's hard.
7.
What?
7.
My dog can do that.
7.
7.
You're right. 7 pi over 6. And of course, we know where that is. So what I do is, whenever I do secant, cosecant, and cotangent, I think of the reciprocal, so I do tangent. What is the tangent of 7 pi over 6? So in the third quadrant, it's positive. It's near the x-axis, so it'll be 1 over root 3. Flip it over, root 3. Because cotangent is, but everybody has whatever, you gotta organize it in your mind however you need to, right? Or what do you guys do, just memorize the darn thing? Okay, never mind.
Yes.
No, I like talking to myself. D, cosine, I'm used to it from my other classes. 241 pi over 3. Now, what would be a good multiple of 2 pi to subtract from that?
240.
Okay, 240 pi over 3. Because isn't that the same thing as 80 pi, which is a multiple of 2 pi? So you get cosine of pi over 3. And I know where that angle is, right there, 60 degrees. And cosine of 60 degrees we know is 1/2. There you go. So make sure you read the directions now. I didn't make I wrote the tests for you guys on, when did I say you're taking it?
Monday.
Monday. I didn't make complicated directions, it's pretty easy to follow. Number 2, find the acute angle, that means first quadrant, in degrees and radians. Because some of you only gave degrees, it says degrees and radians. That satisfies the equation tangent theta equal √3/3. Hey, that's a number I'm supposed to know for tangent, right? Isn't that right here? So that's 30 degrees, and of course the radian measure is pi/6. Yeah. But you have to give both, because that's what Ms. Baker wanted on that one. Number 3, give the angles in the interval now. It says between 0 and 2 pi, so that means you need to give your answer in radians. Because some of you just gave degrees, but if they're giving it to you in radians, they want it in radians. So cosecant theta is equal to -2. Isn't that, now, most students, I don't know, they prefer sine, cosine, and tangent. Well, if you do, then just reciprocatize both sides, like this. Isn't that the same thing? Sine theta equal -half, and I know where that is. I always think of the unit circle when I do these kinds of things. Sine theta equal -half. Right, so where is this in this? So if you do it in degrees, it's gonna be 210 and 330, but they want radians. So that's 7 pi/6 and 11 pi/6. Number 4. Okay, now the next 3 problems, the key is you need to draw your reference triangle in the correct quadrant. So basically, pretty much that's all I looked at is your reference triangle, because once you draw the reference triangle, you can look at it and figure out sine, cosine, tangent, and the other 3, right? So they said the point is 6, -3. So if I go 6 to the right and 3 to the down like this, there's your reference triangle right there. How do I get the hypotenuse? You use the Pythagorean theorem. Now, some people were not simplifying. Does Miss Baker make you simplify? Like, it's supposed to be √45, right, if you use the Pythagorean theorem. But does she make you simplify it to 3√5? Now, I didn't take off points on this quiz because I didn't know. However, on the test, now I know. So you need to reduce, like some of you didn't reduce your fractions. You didn't simplify the radicals. I didn't take off points on this quiz, but on the test, 1 point for simplifying, yeah? Okay, so what do you have? What do you have to find in this problem? You have to find sine theta and secant theta. Well, isn't sine opposite over hypotenuse? Like that? And then, of course, the 3's can cancel out. Now, does Miss Baker let you leave your answer with a radical in the bottom? Okay, then you need to simplify. But I'm going to tell you, when you go to calculus, a radical in the denominator is perfectly fine. Okay? But I'm only going to grade your test once. After that, you got to follow the rules. So -√5/5 would be the preferred answer then, yeah? Secant is, well, cosine is adjacent over hypotenuse, so secant is the reciprocal of that. Hypotenuse over adjacent, so hypotenuse over adjacent. And then you can cancel, right? 3 goes into 6 2 times, √5/2. So the key is, once you get this reference triangle, everything else easy. So you make sure you draw it in the proper quadrant. Make sure you compute the sides correctly, and then you're in the money. I believe, okay, because I made this test. I think there's 2 of these on there. Okay, next page, number 5. Same thing, you got 3 on this quiz. Cosine theta is equal to -7/5, and tangent theta is positive. So first thing you gotta do is you gotta figure out what quadrant you are in. Well, cosine is negative in the 2nd and 3rd quadrant, right? Tangent is positive in the 1st and the 3rd, so that must mean we're in the 3rd quadrant, yeah? So when you draw your reference triangle, draw it in the 3rd quadrant like this. Okay, so cosine is adjacent over hypotenuse, and how do I figure out this 3rd side? Pythagorean theorem. So if you need to do it out, you don't have to do it in your head. Like if you call this x squared plus this squared equals that squared, x squared equals 18, x equals square root of 18, which is 3 root 2. Okay, so is it 3 root 2? No, it's negative because you're going to go down, right? Okay, so that's your reference triangle. Once you draw that, easy. What does it say to do? Find the values of the remaining 5. Okay, so what are the remaining 5? Sine, tangent, secant, cosecant, and cotangent. So just look at your picture. Sine is, okay, this is theta, yeah? Sine is opposite over hypotenuse. No need to reduce that. Tangent is opposite over adjacent. So positive 3 root 2 over root 7. So you're telling me your teacher doesn't like that. Then multiply top and bottom by root 7. Although in calculus, that's perfectly fine. 3 root 14 over 7. Secant theta is, well, once you get these three here, to get these three, you don't even have to look at the reference triangle, or you just reciprocatize these, right? Secant is the reciprocal of cosine, so you get negative 5 over root 7. Cosecant is the reciprocal of this, 5 over, and you can put the negative wherever you want, 3 root 2. And cotangent is the reciprocal of this one. Maybe we should look at that one. Root 7 over 3 root 2. See, in calculus, all these are good. But like you guys said, you need to simplify. So I'm not going to do it. You guys know how to simplify that, right? Okay, the key is draw that correct reference triangle. Number 6. Secant theta is equal to negative 4, and sine theta is positive. So what quadrant are we talking about? Well, where is sine positive? First and second quadrant, right? When is secant negative? That's the same thing as when is cosine negative? Here and here. So well, we must be talking about the second quadrant then. So draw it in the second quadrant like that. So secant is hypotenuse over adjacent. Hypotenuse is never negative, yeah? And then how do you figure out the side? Use the Pythagorean theorem. X squared plus 1 equals 16. X squared equals 15. X equals root 15. So this would be, no, that's already done. This is positive root 15 because you got to go upward, right? That's your reference triangle. So basically when I graded this quiz, I just kind of looked at your reference triangle. As long as it's right, I'm sure you can get everything. But because on my test, I don't think I made you find all the other 5. I just made you find 2 of them. That's good enough for me. So like if I were writing the test, which I did, I would probably ask you what is tangent theta? Opposite over adjacent, so negative root 15. And then I look at this, I might say, okay, cosecant theta then. What is cosecant theta? Hypotenuse over opposite. And then like I said, multiply top and bottom by, and so 4 root 15 over 15. I'm not going to make you find all 5. Okay, and number 7. In the right triangle shown, okay, let me attempt to draw this. What was given? Oh, so this is alpha, this is beta. Sine of beta is 3/7, so opposite over hypotenuse is 3/7. To find the third side, you got to use the Pythagorean theorem. So x squared plus 9 equals 49. Some of you did some computation errors here. X squared equals 40, x equals root 40, but that can be simplified to 2 root 10, right? That's 4 times 10. So make sure you simplify your radicals. And then once you do this, come on, easy money. Well, at least A is easy. Cotangent alpha. Okay, here's alpha. Cotangent is adjacent over opposite. So adjacent over opposite. 3 over 2 root 10, and then, okay, let's just do it. Multiply top and bottom by root 10, and you get 3 root 10 over 20. And then what is part B? I can barely read that. Cosecant 90 minus beta. Okay, now to do this problem, you gotta remember your identities. Remember your co-function identities? What you talking about with this? Okay, let me write it over here. In fact, you need to know this on the SAT now. You guys taking the SAT soon? Okay, you gotta remember this. When two angles add up to 90 degrees, when they're complementary, then the sine of one equals the cosine of the other. So if two angles add up to 90 degrees, like alpha and 9, let's use theta, theta and 90 minus theta, then the sine of one is equal to the cosine of the other. Did you guys ever wonder, hey, there's sine and then there's cosine. Must be they're related somehow, huh? There's tangent and there's cotangent. They must be related. What about secant and cosecant? Yes, they're all related by this identity here. If two angles add up to 90 degrees, then the tangent of one is the cotangent of the other. The secant of one is the cosecant of the other. So here, this is the way we write it. So the tangent of one is the cotangent of the other. If two angles add up to 90 degrees, the secant of one is the cosecant of the other. Okay, so in this problem, what did we just learn from there then? What is the complement of 90 minus beta? Beta, and then the cosecant of one is equal to the secant of the other. That's right. So this is saying the same thing, because some of you are distributing the cosecant. You can't do that, yeah? Remember, we have identity, because you guys took trig before, right? Remember, when you have like cosine of alpha plus beta, can you distribute the cosine?
No.
No, you can't. We have identities for that. I guess that's going to be next chapter, yeah? Remember, does this sound familiar? Cosine alpha, cosine beta, minus sine alpha, sine beta. Yeah, so you cannot just distribute it. So you have to use identities. So secant beta, well here's angle beta. Secant is what? Hypotenuse over adjacent. So hypotenuse over adjacent, multiply top and bottom by radical 10. Final answer survey says 7 root 10 over 20. And then Miss Baker gave you a bonus. So I gave you guys partial credit, and the most you can get is a +3. That's like 6%. Not bad, huh? Okay, so the first thing you gotta do is draw the correct picture. Adorning the top, okay, so basically you have a building. Here's a building, okay? And then on the top of a building, you have a statue. So this part is the statue, this part is the building. From a surveyor that is 6 feet off the ground. So here's the ground. So the surveyor is 6 feet off the ground like this. Okay, I guess you should draw this in like that. So the surveyor is 6 feet off the ground. Two observations are taken 400 feet from the building. So this is 400. Of course, this is 400 too, yeah? The angle of elevation to the top of the building. So angle of elevation is measured from here. So when did you guys cover this? Because on the test, I made 2 problems like this now. One involving the angle of elevation, and you guys remember the angle of depression? If not, make sure you do that practice test I gave you guys, because it's almost exactly like the test, except different. Okay. So the angle of elevation to the top of the building is 55.1 degrees, and the angle of elevation to the top of the statue is, I'll draw it like this then, 56.5 degrees. What is the height of the statue? Now the other class told me that, didn't I ask you how many decimal places? when you guys were taking the quiz?
Yeah.
Okay, so to prepare for calculus, just automatically do 3 decimal place accuracy. But also, if you're gonna have 3 decimal place accuracy, you cannot use a rounded value in another computation. So if you wanna get 3 decimal place accuracy, the best thing to do is use all the decimal places. Just round off your final answer. Because otherwise you're gonna be off in the 3rd decimal place. But for those of you gonna take AP Calculus next year, if you are off in the 3rd decimal place, you lose the whole answer point. The whole thing is wrong. Well, the answer point anyway. So that's why you have to be correct. You gotta practice being correct in 3 decimal places. So the best thing to do, I guess to be safe, use 5 decimal places, but I would just say use them all. That's probably the best policy there. Okay, so what are we trying to find? The height of the statue. So my algebra teacher taught me anything, whatever you're trying to find, label that X. And then, yeah, well, Mr. Park, we don't know what this is. Okay, then call it a Y then. And then we want to start to write equations. So let's look at the smaller triangle first. Look at this triangle right here. This triangle right there. So here's the angle, 55.1. This is the opposite side, and this is the adjacent side. Which of the 3 has opposite and adjacent in it? Tangent. So write a tangent equation. Tangent of 55.1 degrees is equal to opposite over adjacent. Multiply both sides by 400, and you get, a lot of people did this, right? I think, if I remember correctly. And that can be punched in on your calculator. But then you gotta use all the decimal places now. Now look at the big triangle. This angle is 56.5 degrees. And again, opposite over adjacent, that's tangent again. So the tangent of 56.5 degrees is equal to opposite, which is x plus y, over adjacent, which is 400. So x plus y is equal to 400 times the tangent of 56.5 degrees. By the way, on the test, I'm not gonna let you use a calculator, so you're just gonna, the directions say just write an equation that solves for y, for example. So then you just leave your answer like this on the test. Because I'm assuming everybody can punch it in on your calculator, yeah. Okay, anyway, punch this in on your calculator. Punch this in on your calculator. So if you know what y is, and then you know what y plus x is, how do you figure out what x is? Yeah, just subtract the 2, and then you get the answer. So this is the final answer. Where's my final answer? 30.948 feet. That is the answer. Because some people are off over here, or some people didn't even give you enough decimal places, so. Anyway. Any questions on this? So how many people actually started the worksheet I sent you? Oh, that's almost everybody, good. Okay, so since we just learned it, my feeling is probably the hardest part for you guys is the graphing, yeah? Because you guys covered everything else, right? So what we're gonna do for a few more minutes, we'll do some graphing practice, and then if we have time, then we can play a game again. Who won the last game? Boys. Well, I'm getting it mixed up with the other class. I think the girls were leading like 7-3, and the boys ended up winning. First to 10.
It's hard when they're all like all the first ones are things that both people.
Oh, because they're athletes, that's why.
And then the athletes happen.
But that's okay, today it's a totally different game.
Yeah.
Doesn't have. Okay, so graphing. Okay, so yes, I already told you. Okay, so the first graphing problem is I'm going to give you a sine curve. You have to write a sine and a cosine function for it. So let me just make up something here. Okay. Okay, I've got to concentrate here. Don't worry, it's gonna be nicely drawn. I made it on my calculator and then you can, so it's not gonna be hand drawn like this. Okay, so this would be, gotta look at the scaling now. This is 6 and negative 6. And on the x-axis, let's say that this is pi over 2, negative pi over 2. Okay, so on the test, you're gonna have to write a cosine function and a sine function for the graph. So what's the first thing you should do? A, stare at it. B, skip to the next problem. C, look for the amplitude and period.
C.
Wait, let me think about that, Mr. Park. I think I'll go with C. Yeah. So what you should do is draw in this line right here. Draw in this line, use the midline. So what is the amplitude? Isn't this the amplitude like this? Right there? So what is the amplitude?
3.
It's 3, right? Because if that's 6, this is 3. So we know the amplitude is 3, so I'll just put it in the middle because it's the same for both. What about the period? Well, come on. Like that. Isn't this one period right there? Right?
Yeah.
To make one cycle, and then it just starts repeating itself. So how far is it from 0 to pi over 2?
Pi over 2.
Okay, so the period is pi over 2. Did you guys learn this? 2 pi over b is the period for a sine and cosine function. I mean, you don't have to know that, but it makes it a lot easier if you do. So 2 pi over b is equal to pi over 2, because that's the period. And then can you solve for b?
Yeah.
You bet your bippy you can. The pi's cancel out, cross multiply, and you get b equal 4. Woo! So we can write almost the whole function now. So the cosine one, you go y equal 3 cosine 4. Now the base graph would be like this, but then obviously you can see that it got shifted left and right and up and down, yeah? So then this is the base graph, and then you gotta do things to it. So, what do I look for, Mr. Park? Well, doesn't a cosine graph look like this? Right? Right? Doesn't it start up here at the maximal? So this is what I do. I look for this right here. Because like there. Isn't that one period right there? Okay? So the first thing I do, look. Normally it starts there at 0, but over here, it starts over here. And where is here? What is this? If this is negative pi over 2, that means half of it would be negative pi over 4, which means that would be negative pi over 8. So that means the graph got shifted pi over 8 to the left. Correct?
Yes.
Okay, so how do you make a graph shift pi over 8 to the left? Plus pi over 8. And then, normally, cosine and sine, the midline is right on the x-axis, right? But now it's up here. So doesn't that mean the graph got shifted up 3? How do you make a graph go up 3? Just put plus 3 at the end. Ding! Full credit. Of course, there's many possible answers. Like, couldn't you have shifted, instead of shifting it pi over 8 to the left, couldn't you have shifted it over here? Okay, now where is here? This is pi over 4. This would be 3 pi over 8. So instead of shifting it pi over 8 to the left, you could have also shifted it 3 pi over 8 to the right. So you could have also had x minus 3 pi over 8 there. That's perfectly fine as well. And there's an infinite number of answers because the graph goes on forever, right?
Yeah.
I'll take anything that's correct. Okay, now what about sine? Well, is the period and the amplitude going to be the same? Yeah. So you can go y equal 3 sine 4, and then now we got to do stuff to it. Now remember, sine starts here, right there. Right? So where do I see that? Like right there. We can do right there, right? See? Like that, from here to here. Or you can do it from here. Which one do you want to do? The left one or the right one? Okay, the left one. So the sine graph starts right there, right? It makes one cycle like this. So that means I have to shift it pi over 4 to the left. How do you shift a graph pi over 4 to the left? plus pi over 4. And then same thing, look at the midline is over here, so don't you have to shift it 3 up? How do you translate 3 up? Plus 3. So that would be one possible answer. But then, like I said, couldn't we have translated it pi over 4 to the right instead? So instead of this, you could have had x minus pi over 4. That would be also correct. Or, some of you are go, hey, what if I do a negative sign graph like that? Mr. Park, don't give me too many options. Look, right here, a negative sign graph is like this then, right? So you could have gone negative 3 sine, and then you don't even have to shift it left or right, right? Because that's where it starts, but you still have to go up 3. So any one of those 3 would be good. Just give me one of them. Okay, now the other 4, like I told you, you're going to have to graph it by hand. Okay, we'll just do one. So did you guys practice the humping technique?
Yes.
Okay, so, or you guys forgot all about humping? Okay, let's just do one then. Because you guys need to practice it. Okay, so we'll just do one more, and then you guys practice the rest. Okay, y equal, which one do you need to work on?
3 cosecant.
Cosecant. Okay, cosecant. Cosecant, let's put a 2. Let's throw in the words. Put in a minus. I'm trying to concentrate here. How about pi over 4 x plus, shh, 2. Okay, and I'm not going to even make you shift it up or down because after doing this problem, you proved to me that you know how to shift up and down. Because it gets kind of messy too. Okay, so like what did I tell you last time? This is what you want to graph. You graph this first. Remember, you gotta do that. Where's the thing? You gotta do this and this first. And then, so after you do the stretching and shrinking, then after that, then you do the translating, yeah? So graph this first, and then what does this do? Shifts it 2 to the left. Okay, so just worry about this. So draw the base graph first. Remember the base graph? Cosecant is the reciprocal of sine. So what you do is draw the sine graph. And then hump it. Whenever the graph touches the x-axis, vertical asymptotic. And then if the graph humps down, you hump up. If it's humping up, you hump down. In fact, I was looking at your book. They have this exact same picture. Of course, they don't mention the word humping, but it's the same thing. But then you guys said you guys don't even look at the book? So what do you guys look at? Just the problems?
The notes.
She has notes that she gives us.
Oh, she has her own notes.
Yeah.
Does she mention the word hump?
We didn't graph these.
Oh, go the other way. Okay, never mind. I just showed. Okay, so first of all, what does this do right here? This will multiply the x values by the reciprocal of that number, 4 over pi. So if you multiply this by 4 over pi, the pi's cancel out. So whatever number there, no matter what it is, you multiply the x by the reciprocal of that number. And what do you get? It rhymes with mate. 8, which of course means this is 4, this is 2, and this is 6, right? You don't have to do that. You can just put 8 there, that's good enough. And then, what does the 2 do? It multiplies the y values by 2. So instead of 1 and negative 1, it's going to be 2 and negative 2 now. Now what does the minus sign do? It reflects it over the x-axis. So instead of humping up, it's actually humping down over here. And instead of humping down, it's humping up. So this red graph is that graph right there. Okay, and then just one more thing we got to do. We got to shift it, right? Because We just graph this, we gotta do this. What does this do? Shift everything 2 to the left, so everything goes 2 to the left. So here it's -2. So I like to do the asymptotes first. So you see the 3 asymptotes? Move them all 2 to the left. And then the final masterpiece will be in orange. Okay, so this moves 2 to the left, so shwing. And, oh, get so many colors here. Shwing. And there you go. The orange graph is the final product. Now on the test, it says to graph 2 periods now. So once you get this, you copy, and I don't care if you paste it here, or you want to copy and paste it here. It's up to you. You guys can copy and paste, yeah? Okay, so you guys need to practice this on your own. I gave you guys complete solutions as well, right? Did you guys look at that? Did they help?
Yeah.
Good thing, good thing I didn't come to school 5:30 yesterday for nothing. All right, what time is it? We got 10 minutes left, we can play a game.
Yay.
Okay. You know what I spend my time doing? Well, this is with my, like I'm walking around or driving, I think of a game, ting, and then I go home and I make it. So they do. So this is an old game. I made this game long ago. In fact, if you were in my SAT prep class, you might have played it. Is it coming on? Oh, boy. Yes. Okay. Okay, this is called Disney Villains. You guys ever heard of Disney? Walt Disney cartoons? Okay, it's gonna show you a villain. Now it's up, I'll leave it up to you. Do you want to name the villain, or do you want to name the movie he or she came from, or it came from?
The villain.
Okay, the villain. You guys think you're that good, huh?
Yes.
Okay, we'll see.
Disney, right?
Huh?
Is Disney villain?
Disney.
Okay, yeah.
Animated Disney.
All right.
Oh, okay, you guys think you're good? Okay. Boys, girls. One guess per picture now.
Speak up,
Oh,
Kimberly.
wrong way.
I don't know.
This way.
Scar.
Okay, her girls. Scar. Girls.
Maleficent.
Girls.
Gaston.
Girls. What boys, you want to make a comeback, just like the other class, except it was the girls?
Ursula.
Girls.
Captain Hook.
Girls.
Shere Khan.
Girls.
She's hero.
Queen. Evil Queen.
Wait, yeah, it is the Evil Queen, but I believe she had a name. Now I'm trying to remember it. Something like Brumhilde. Nobody got it.
Han.
Girls. Come on, boys.
Lady Tremaine.
Very good. How do you know that?
I don't know, I watched Cinderella.
Yes, Cinderella, that's the evil stepmother.
I have no idea.
Jafar.
Okay, that was a tie, so the rules are, if it's a tie, the losing team gets the point. Boys, you're on the board.
Go Dylan. Oh, shit.
Girls. Hopper.
Sid!
Girls.
Oh my gosh, I love him. Oh.
Okay, I'll give you a hint. It's from Pinocchio. Who's Pinocchio?
It's not.
Stromboli is his name.
Oh. Randall.
Girls, girls. It is 13-1.
Oh.
From Mulan. No. Sean Yu.
Okay. Dr. Facilier.
Yep.
Do it.
Now what's the movie again?
Princess and the Frog.
Yeah, that's it. This is from Tarzan. I think his name is Stanley?
Oh.
Clayton Stanley or something?
The Siamese cats?
Okay, but they have names.
Or did they?
Yes. From Lady and the Tramp. Their names are Sai and Am. You get it? Siam. The former name of Thailand. What's Thailand?
Oh. Mr.
Oh gosh, I might not even know this. I know it's from the Black Cauldron. Huh? The King of Thorns. That sounds right. I'm gonna give the boys 5 points for that. Except I'm marking out 1.
Oh.
Like Bantu or something.
It might be. This is from Lilo and Stitch. Is Gantu the bad guy? What about this? Could it be Jumba?
No, Jumbo was the big fat one. The fat one with a lot of eyes.
Okay, so this is Gantu. Okay, I trust you. So did you guys get it? Okay.
Wait, another Gothel.
Yep. Girls.
And Yzma.
Girls.
Oh. Mm.
I think this is the Rescuers, yeah?
Yeah.
Her name is Madam something. Okay, well, nobody got it, so, yep.
Kennedy.
Okay, tie, boys get it. It wasn't really a tie, but they're so far behind.
The Fates?
No, that's Donald Duck.
Oh.
You guys never saw Donald Duck in Mathemagic Land? Oh my goodness, we watched that in my pre-calculus honors class. Okay, you know what, now it's getting hard. Now just give me the movie then.
Ratatouille.
Okay, girls.
Incredibles.
Oh, can we?
Boys, so, because that was a tie.
Fox and the Tramp?
The what?
Fox and the Hound.
Fox and the Hound is correct. Oh, huh? Who said that? That's correct. Who said that?
I cheated. I
Okay.
helped the boys.
Okay, wait, Mr. Shimizu got his own team. You're on the board.
Oh, wow. Shit, I didn't know I could play.
Cars,
Cars.
2. Oh.
No, it's Cars 1, just boys got down.
Fox and the.
No. Song of the South.
Song of the South, that's a good one. How do you know?
I don't know, Splash Mountain.
Exactly, that's exactly right. Yeah, but now we're naming the movie.
Robin Hood.
Robin Hood is correct. Okay, there's only 2 minutes left, so I don't know how many pictures are left, but so the boys can catch up. Each one is going to be worth 4 points now.
This is.
But boys are down 20-6.
Oh.
No, you know what? We're going to make it a touchdown then. Six points for a correct answer. Dumbo is correct.
Jeez, Dylan.
Hunchback of Notre Dame. That's a movie.
You're right. It is. I had to think.
Fantasia.
Yup, Fantasia. Oh, look at boys catching up.
The Aristocrat?
Girls,
Oh, Pocahontas.
girls. You got 1 minute left.
Treasure Island.
No. Pokemon, who said that? This is the Rescuers Down Under.
Oh.
Moana.
That's a tie, so boys get it.
Atlantis.
I forgot. I don't think that's it though.
The
3 Pigs.
Okay, I heard the boys say 3 pigs. Okay, so boys, if you get this one,
Oh.
you will take the lead right here.